Yeah, no, like you saying how like pornography.
When you eat that big old cheeseburger, it just sits right there.
Yes, this is usually what happens. You know how you might hear people say, well, I have clogged arteries? What they're telling you is they went and checked out the, they can now go through the arm. It used to be they went through the leg. And what they're doing is they're checking the circulation around the heart. And if these arteries have buildup of plaque, which is the clogged portion that people refer to, which is really the cholesterol that a lot of people think about, that's where it's building up. And that's where it's, now it can build up in other areas of the body too, but this is where, becomes the issue. And so let's say that this portion was 100% clogged, chances are that person's going to have a heart attack right there in that portion of the heart. And when they have the heart attack, the blood flow stops completely. And the thing about the heart tissue, it does not repair. And so whatever cells were attached to that blood flow, they die. They don't come back. And so if they survive the heart attack, it might be they don't need bypass surgery because the rest of the heart is still healthy enough to keep functioning. Or they might say, well, let's try to change your diet. Let's try to lower that cholesterol, blah, 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 blah. And hopefully it will stay healthy. Sometimes, though, if it begins to continue to move up and up and up, then they might say, okay, we need to do a bypass, take this portion and put it to another side. That's kind of cool. Gotta admit, that's kind of cool. So, when the heart beats and then relaxes, that's when the coronary circulation begins. So, in our regular circulation, when the heart beats and it pushes to the lungs and the rest of the body, when it relaxes is when the circulation around the heart can go. So every heartbeat, you not only get the circulation to the pulmonary circuit, you get it to the systemic circuit, and then when it relaxes, you get it to your heart. And then, by way of the veins, they follow the exact same pathway as the arteries around the heart itself, but their job, pick up all the waste and return it to the heart. For the veins, all right, there is a little bit that returns. There are these little teeny tiny vessels called the Vesian veins. You might hear that sometimes. It's kind of rare. People can actually have issues with those. All right? But the majority goes by way of something called the great cardiac vein, which, guess what, is in the sulcus that goes around the heart. Right there. This is what's going around the heart. This great cardiac vein is getting the blood flow back from all of these other veins. These are on the anterior portion, will simply just flow around, make their way to the great, and guess where the great empties? It empties, because it goes toward the coronary sulcus, the groove, okay, empties into my coronary sinus, a hole. Right there. So the blood flow coming back from the organ of the heart itself empties right into the right atria.
And is there a particular place like on the heart where it leaves to go right back into the heart, or is this one that goes through the entire body, including the heart?
Now, when you say
So like if you flip back to that picture.
this one,
Nope, the one before it. So you've got the coronary that brings blood back from the heart.
right, that's
Is
what I
there
was saying.
anyone?
The blood that comes back to the heart by way of the great cardiac vein comes from right there.
So is
It's
there
a little sinus, a little opening.
another one that just takes blood directly to the heart from here?
Well, for the coronary artery, that's where I pointed out those. Taking it to the heart.
Where is that on the grand scheme of the heart, though? That's what I'm asking.
We don't have a very good view,
Okay.
okay? But on the aorta, they would be right there on these sides
Okay.
of the aorta.
So it like meets with the inferior cava?
Well, when you look at the flow, okay, remember my superior and my inferior vena cava. That's bringing blood flow like from the upper head, like the inferior from the upper head, upper extremities, neck to the heart. The inferior is bringing it from everything heart down back to the right atrium. So blood return, whether we're talking the systemic circuit or now my coronary circuit, both empty into my right atrium. Does that make sense? So that's a really cool structure that I now have. Because like I was showing earlier, the veins, they're collecting, just like I had blood flow from the arteries, veins are returning it. So I have veins basically following the exact same pathway. Anterior, posterior, marginal, or lateral. To return the blood flow from the circulation of the heart itself. Does this make sense? So the structure of the muscle, because cardiac muscle is that working unit, okay? It is the part that is going to help with the heartbeat. Heartbeat should usually somewhere between 60 to 80, all right? Norm is usually around 70, 75 per minute. That means 75 of them per minute. So it's represented as beats per minute, BPMs. Our heartbeat is considered myogenic. Myo meaning muscle, genic meaning the start. Meaning it originates in the heart itself. The heart is innervated, but it does not depend on the nervous system to function. The heart is autorhythmic. The heartbeat, the SA node, the one that I mentioned before, that's your pacemaker. Cardiac muscle, the portion here, okay? The part that is actually the cardiac cells, okay? It's called cardiomyocytes. Heart muscle cell. These are the muscle cells of the heart. Their connection forms a network through the chambers. Do you guys remember in part 1 when you were studying the 3 types of muscle? Skeletal, smooth, and cardiac? When you looked at them under the scope, muscle cells were very tubular. Cardiac cells were tubular but looked branched. And then they had those marcated lines that were present. And those were the intercalated discs, meaning cell to cell to cell to cell. Each area going from one cell to the next is an intercalated disc. It actually looks like if this was one cell meeting the other, the way that they would match up is it would be like step-like fashion, like step, step, step in between the cell. They're said, because of that structure, they interdigitate, digits, like the fingers, because it looks like they interdigitate in a step-like fashion. This interlocking that they do increases surface area. Anytime I can increase surface area, I can increase movement of materials. It's a little bit interesting now. They're going to have some mechanical junctions. That simply means some type of structure is present. If they have to interdigitate, you will find part of a protein in this one going through the membrane in this one. Think of like Velcro. Anybody ever peel it and put it back together? And it kind of does this overlapping, okay? One of the things about it, those proteins act like Velcro. Part of it is in this cell, part of it is in this cell. When they come together, they lock. Those are called fascia. Fascia means it creates a sheet. When the heart beats, it looks like it beats in one motion. That it's like, it is actually these sheets of the cell with each cell working independently, but they're so organized, it looks like it's one action. That can change, and that can create issues. Irregular heartbeats, for example, that means they are no longer on the same page. No pun intended. That makes sense? Then they're held together with little desmosomes. You guys remember the little desmosomes between the plasma membranes of stuff? And that just simply helps hold them together. I mean, I don't know about y'all, but I don't want them falling apart. And then gap junctions. Do you guys remember those in between two cells? Just like the name implies, it's a gap. Guess what gets to move? You're reading it, Brian. I see you. The ions. Because, once again, we're in muscle cell. Muscle cell works based upon what we think of as electricity. And the electricity is